Hello everybody, welcome to a brief introduction to crypto ideas and terminology continued. This is the second video, and like the first video, this is aimed toward my friends and toward non-technical people who want to understand cryptographic terminology without understanding all the mathy stuff. Basically anybody who's interested in an introduction to all the fancy crypto magic that they hear about without all the internals. Therefore, it's not for technical people with a strong background or people with a master's, bachelor's, or PhD or equivalent knowledge in math, computer science, or security. If you have any of these qualifications, go do the real thing. It'll be much better for you. In this video, I want to talk about hardness or difficulty, which is something I should have explained in the last video. I also want to talk about one-way functions, hashing, and signing, so it's going to be a lot in this 10 minutes. Hopefully, I can fit it all. So, in the previous video, I mentioned that it is impossible for an attacker or somebody to decrypt a message unless they know the secret that is necessary to decrypt it, and this isn't completely true. What I should have said is that it's very hard or difficult for them to reverse that encryption. For example, actually, what I mean by hard or difficult is very different from when we say hard or difficult in regular terms. What hardness or difficulty means in the cryptographic sense is that there's no efficient algorithm or technique to do this. And what I mean by efficient is if we were to try to do it, given our modern computations and algorithms and understanding, it would take hundreds or maybe thousands or even hundreds of thousands of years. So with that understanding of what hardness is, let's continue. First, I'd like to talk about one-way functions. And as the name suggests, a one-way function is a function that, given an input, it is easy to compute an output. And given an output, it is very difficult, very hard to compute an input. In addition, one-way functions have a property of taking a variable length input. So if you think of this as a word with any number of letters, just choose any word. Every single time you put it through the one-way function, the same one-way function, you get a fixed length output. Meaning if you run it through this specific one-way function, you always get an output of 2 or 3. So let's do an example. This one-way function, we define the one-way function as taking the second and fourth letters of the word and throwing out the rest. So as you can see, you'll always end up with an output of 2. And if we were to have the input hello, it's easy to see that E is the second letter, L is the fourth, so EL is always going to be the output. But if you have just the output, just the EL, it is very hard to know what the real input is, unless you have some other context. So in this example, it could be hello, or deflate, or feeling. Could be any of these. We simply don't know because all we know is that we take the second and the fourth letter, and in all of these, the second and the fourth are E and L. So, we take this one-way function and we expand it into an idea called hashing. And hashing is a one-way function with 4 properties. It's easy to compute if we have an input. So we take the input, it's easy to get the output, just like in a one-way function. It's hard to generate the input if we have the output, also like a one-way function. But this is where it's going to deviate from the rest of one-way functions. It's hard to modify a message without modifying the output, the hash. So if we were to go back to our hello example, this is easy to modify the message and get the same hash. I can add the letter S on the end, and this would become hellos. And we would still get the same output or hash EL. So this wouldn't qualify as hashing. This is simply a one-way function because it doesn't fit with that third requirement. In addition, there's a fourth requirement, that it's hard to find 2 different messages with the same hash. Again, our previous example violates this. Given the hash EL, or given the message hello, since we know that the hashing function is to take the second and the fourth letter, it's easy to find words like deflate or feeling that have the same hash as hello. So these are not, this previous example is a one-way function, but it's not a hash. What hashes tend to look like are a series of letters and numbers and just large numbers represented in the computer. And they satisfy all four of these requirements. So let's talk about hashing and what it's useful for. Let's say I were to send you a file. How do you know that that file wasn't modified in transit? So what I can do is I can send you the file, and in addition, in a way I deem secure, I can give you the hash of the file. So that this way, you can, once you receive the file, hash it yourself and check if those two hashes are the same. If they are, you know that this is indeed the file that I intended to send you, because I gave you the hash, and the hash I gave you fit with the hash that you computed yourself. Likewise, because of the properties of hashing, you know that it is very unlikely that somebody else managed to give you a different file that came out to the same hash. So, this is great. It solves one problem. How do you know it's indeed the file that I sent you? And that's an important problem to fix. But another problem is, how do you know it's actually me who's sending it? This is where we expand the idea of hashing into signing. So, again, I send you a file. How do you know it's me and not Satan? Very well could be Satan. For this, we're going to leverage the fact that public key cryptography has a public portion and a secret portion. So I always hold my secret key, and I never give that to anybody else under any circumstances. But my public key can be sent to anyone. So what I'm going to do is I'm going to take the file, I'm going to hash the file, and then I'm going to send the file to you. And in addition, I'm going to take the hash and I'm going to encrypt it with my private key, the key that only I have access to. Then I'm going to send the resulting encryption, the resulting ciphertext, over to the recipient. Now, it is important to remember that the public key can reverse the encryption process that the private key does, and vice versa. So, given the hash that was encrypted with my private key, you can take my public key and decrypt it to get the hash back. You then hash the file and compare the two resulting values. And this shows you a few things. One, it shows you that the file was not modified in transit because the hashes match up. And two, it shows you that nobody else but me could have sent this file, because I am the only person in this universe that has access to my private key. So that was a brief introduction to hardness, to one-way functions, to hashing and to signing. I hope next time to cover a few more interesting topics at roughly the same level of detail. Thank you very much.